Hello everyone, welcome to my YouTube channel. This is Megha K. Currently pursuing my education in Sri Venkateshwara College of Engineering, Bengaluru. Section Astrosat, Department is Electronics and Communication. Subject name is Mathematics for EC Engineering stream. Subject code BMATE 301. Topic is about least square method in curve fitting. Let's talk about the introduction to curve fitting. Curve fitting is statistical technique used to create a curve that best describes a set of data points. It allows for the modeling of relationships between variables in various scientific and engineering fields. The objective is to minimize the difference between the observed data points and the values predicted in the curve. Let's talk about some key points in curve fitting. Data points, a collection of observed or measured values often represented as XY pairs. Second one is model function, a mathematical function, for example linear, polynomial and exponential, that is chosen to describe the underlying trend of the data. The point 3 is best fit, the curve that minimizes the disparity between the observed data points and the values predicted by the model. Fourth one is error metrics. Common methods to evaluate the quality of fit include sum of squared errors, mean squared errors, root mean squared errors, R squared. What is the least squares method? The least squares method is a mathematical optimization technique used in regression analysis. It minimizes the sum of squares of the residuals, which are differences between observed and predicted values. This method can be applied to linear and non-linear models to fit the best fitting curve. Mathematical formulation. The method involves solving the equation Ax equals b, where A is the design matrix of the model. The objective function is given by MINAXB cap 2, which represents the squared residuals. The solution is typically obtained using matrix operations such as normal equations or singular value decomposition. Types of curve fitting. Curve fitting can be categorized into linear and nonlinear fitting. Linear fitting assumes a straight line relationship between the independent and dependent variables. Nonlinear fitting involves more complex relationships, often requires iterative methods for optimization. Let's talk about the applications of least squares method. This method is widely used in various fields such as economics, biology, and engineering for data analysis. It helps in predictive modeling and forecasting by hitting historical data to a mathematical model. Researchers and analysts can draw meaningful conclusions by understanding the trends identified through curve fitting. Example for curve fitting. Consider a scenario where we want to fit a line to set a data points representing temperature over time. The least squares method will yield the slope and intercept values that minimize the error in prediction. The resulting linear model can then be used to predict future temperature values. Example for nonlinear curve fitting. Nonlinear curve fitting may be used to model phenomena such as population growth or radioactive decay. Techniques such as polynomial regression or exponential fitting can be applied to find the best fit. The least squares method is still used but requires more complex algorithms to converge on a solution. Curve fitting, while a powerful tool, comes with several challenges that can affect the accuracy, reliability, and interpretability of the results, here are some common challenges in curve fitting. Overfitting, underfitting, selection of model type, noise in data, outliers, multicollinearity for multivariate models, third condition data, over-reliance on metrics. Overfitting occurs when the model becomes too complex, capturing noise rather than the underlying trend. Underfitting happens when the model is too simple to capture the essential patterns in the data. Choosing the right model and validating it using techniques like cross validation is crucial for effective curve fitting. Tools and software for implementation. Various software packages and programming languages provide tools for performing least square fitting. Popular choices include Python's NumPy and Scipy libraries and MATLAB and R. These tools simplify the implementation of the least squares method, making it accessible for the users. Conclusion. The least squares method is a fundamental approach to curve fitting that effectively models relationships in data. Curve fitting is a vital technique in data analysis, enabling us to model relationships, analyze trends, and make predictions based on observed data. By choosing an appropriate mathematical model and addressing challenges like overfitting, underfitting, and noise, curve fitting provides insights into complex systems across diverse fields such as science, engineering, and economics. To achieve successful curve fitting, it is essential to understand the nature of the data and its underlying trends, select or design models that balance simplicity and accuracy, use robust evaluations metrics and validation techniques to ensure reliability. Understanding its principles and applications can enhance analytical skills in various domains. By leveraging this method, researchers and practitioners can derive insights and make informed decisions based on their data. Thank you. Don't forget to like my video.